Hi, everyone. So far, we have talked about some of the fundamental concepts in statistics, things like samples, populations, different types of variables, different types of studies. Most recently, we've been talking a lot about distributions, how to look at the frequencies of various scores and imagine sort of the patterns that they follow and whether those patterns are symmetrical or skewed. Today we're going to go a little bit further, and rather than talking about the entire distribution and its shape, we're going to be talking about measures of central tendency. In other words, can we take our entire distribution and reduce it down to one number, one value that represents the quote unquote average or typical person in our sample? So that's the definition of what a measure of central tendency is. We're taking our entire sample of people and we're trying to reduce it down to one single number that represents the average person or the typical person. These are going to be things that I'm guessing most, if not all of you, are familiar with. We're going to have three options for measures of central tendency. And what we'll talk about today is some situations where it might be better to use one than the others. The first one is called the mean. The mean is probably what you think of when you hear the word average, because the mean is the arithmetic average of all the scores. We take all the scores, we add them up, we divide by the number of scores, and that gets us the mean. We also have the median, which is going to be the score that falls right smack in the middle of our sample. So by definition, half of the people in our sample will have scores that are greater than the median, and the other half of the people in our sample will have scores that are lower than the median. And finally, we've got the mode. The mode, as we'll see later, is used primarily with categorical variables, not continuous ones. So usually the mode tells us which category has the most people in it. But the mode, generally speaking, is the most common score, the score with the highest frequency. Or if you're thinking about it in terms of a histogram, the mode is going to be the tallest bar on our histogram. So our first option is going to be the mean. Now, again, I'm kind of assuming that everyone has learned this stuff before and that you all know what the mean is. To calculate the mean, what we're going to do is we're going to take all of the scores in our sample, we're going to add them up, and then we're going to divide by the number of scores. Now, in statistics lingo, what you're seeing on the screen, which is the first formula we've actually seen all semester, is how we explain what exactly we're doing here. So first thing to notice is the way that we represent the mean is going to be with a capital italic M. So anytime we calculate the mean score of our sample, we're going to denote that with a capital italic M. The top part of this equation tells us to add together all of the individual scores in our sample. That first symbol you see there is the Greek letter sigma, which probably does not come as a surprise to those of us who are involved in Greek life on campus. Anytime you see sigma in a mathematical formula, it's telling you to add a bunch of things together. So in this case, it's telling us to add together all of the x scores. X is going to be the letter that we use for each individual person's score. So every participant has a score, every participant has their own X. So we're going to add all of the X scores together from all of the people in our sample, and then we're going to divide by the number of people in our sample, which, as we talked about previously, is going to be a capital italic N that tells us the size of our sample. So all this formula is doing is what we already assumed that it would do, right? We know how to calculate the mean. These are the symbols that we're going to use to demonstrate that. Now, in the overwhelming majority of cases, the mean is going to be the measure of central tendency that we're going to use. I'm going to say 98% of the time, that's the one that people rely on, which is why mean and average tend to get used as synonyms. However, there are some situations where the mean might actually not be the best measure of central tendency for us to use. For example, if I were to ask you, how many nipples does the average person have? You would probably say, well, that's a ridiculous question, right? The average person has 2. How many legs does the average person have? Again, you would say that's a stupid question. The average person has 2 legs. But as you know, that's not necessarily true of everyone. And in fact, if we were to calculate the mean number of nipples that a person has, because a small percentage of the population has 3, we would actually say that the average person has 2.05 nipples and 1.99 legs. Now that's if we use the mean as our definition of what is average. Now obviously that doesn't make a whole lot of sense, right? If we're trying to describe the most typical person, then we're going to say that they have 2 of each of these things. So when might the mean not be a great option or the best option for communicating what the average person is like? Here's one situation when the majority of people have the same score, right? The overwhelming majority of people have 2 nipples, 2 arms, and 2 legs. But there's a few unusual cases that people might have more or less of one of those things, but those are far from being typical. Now, speaking in broader terms, the situations in which we might not want to use the mean is when there are outliers or unusual scores in our sample. So one advantage of the median as opposed to the mean, which we'll see in a second, is that the mean is influenced by unusual scores, which for now we're going to call outliers. But the median is not. So in some situations, and we're about to see a few examples of this, the median might actually give us a better idea of what the average actually is. Now, before we do that, let's just quickly review how to calculate the median. As I mentioned before, the median is the middle score. So by definition, 50% of the people in our sample will have a score that is greater than the median, 50% will have a score that is below the median. And just to reiterate, the median is going to be the best measure of central tendency to use in situations when we have some unusual extreme scores in our sample that might make the mean misleading. So imagine sitting in a coffee shop, right, and Bill Gates walks in and sits down at the table across from you. Bill Gates is an extremely, extremely rich dude. So compared to the other people in the coffee shop, he has a lot more money. He is an extreme score or an outlier. But if we were to calculate the mean income of people in that coffee shop, the average person would probably be a millionaire. Because most people make not a lot of money, he makes enough money that he pulls the mean upwards and makes it not realistic. Here's an even simpler example of that. Imagine that we survey 9 people and we ask them to report how much money they make in a year. And here are the numbers that we get. So the first person says I make $32,000, one person makes 35, one person makes 37, and so on, all the way up to one person who makes $260,000 a year. Now, if we took the mean of those 9 numbers, we would say that the mean income is $67,000. Or in other words, that the average person in this sample makes $67,000. Now, you probably see where I'm going with this, right? That could be interpreted as misleading. Because even though that technically is the mean of those 9 numbers, 8 of the 9 people in our sample make less than that. So you could argue that that's actually not a good reflection of what the average or typical person looks like. So instead, maybe we want to take the median. So how are we going to do that? Anytime we calculate the median, the first thing we need to do is take all of the scores from each person in our sample and line them up from smallest to largest, which I've already done for you on the slide here. Then, to find the score that falls right smack in the middle, we're going to cross out the highest score and we're going to cross out the lowest score. And then we're just going to keep doing that, crossing out the lowest score, crossing out the highest score, until we're left with just one score in the middle. In this case, the median income of these 9 people would be $42,000. Half of the sample makes more money than that. Half of the sample makes less money than that. And again, you could argue that the median in this case is a more accurate representation of what the typical person's income actually is. As a quick side note, In this particular example, we had a sample of 9 people. So we ended up with one number that was directly in the middle, 4 numbers above it, 4 numbers below it. How would we calculate the median if we have an even number of people in our sample rather than an odd number? So imagine that we instead asked 8 people to report their annual income. These are the same first 8 numbers from the previous slide. And to calculate the median, we're going to do the same thing that we did before. We're going to cross out the lowest number and the highest number, and then we're going to do it again, and then we're going to do it again, until we get to a point where we're going to be left with not one, but 2 numbers in the middle. In this case, 41,000 and 42,000. The median is going to be the number that falls right in between those two. So if we have an even number of people in our sample, and we go to calculate the median, we're going to be left with 2 numbers in the middle. Our median is actually going to be the mean of those 2 numbers. So in this case, our median would be $41,500. Now you might recall that one of the questions that I asked you on the class survey that we took a few weeks ago is to go into Google Maps and actually figure out how many miles your parents live away from Towson's campus. So if you were living on campus, in other words, how far would you live away from your parents? The reason I asked you that is because I'm going to show you a map in just a second that shows us for the entire United States what the median distance is between a person and where their parents live. As it turns out, the typical American, and again, they're talking in terms of the median here, the typical American only lives 18 miles from their parents. And if you look at the map here, you can see some pretty clear differences between regions. So in Maryland, for example, which is lumped into this sort of southeast region, the median person lives 23 miles from their parents. In other words, in that area of the country, half of the population lives less than 23 miles from their parents, and half the population lives more than 23 miles from their parents. Now, why do you think the median might be a better choice here than the mean? In my opinion, it's because there are probably a small number of people who live very, very far away from their parents, and those people would be outliers. And by including those people, if we were to calculate the mean, we might end up with an unrealistically high number, right? That makes it seem like people live really far away from their parents, when in actuality, it's just a small number of people that are causing the mean to be higher than it otherwise would. By using the median, we negate the influence of those really extreme, unusual people who live really far away from their parents. If we were synchronous or in person right now, we would talk a little bit about why these regional differences might exist. For example, in New York, New Jersey, and Pennsylvania, the average person lives only 8 miles away from their parents, whereas out west in Utah, Wyoming, Idaho, and so on, the average person lives 44 miles from their parents. One obvious explanation for that might just be the layout of those cities and states, right? New York is very densely populated, so you might live in New York City, and so does your parents, but so you're only 2 or 3 miles away from each other. Whereas, in Wyoming, you might live 40 miles from your parents, but that might be the next closest house, because people have a lot more land and the houses are a lot more spread out. I would argue there might also be some cultural influences here. For example, look at the Deep South, Kentucky, Tennessee, Alabama, and Mississippi. The average person in those states only lives 6 miles from their parents. In other words, half of the people who live in those states live less than 6 miles away, very close to where their parents live. It makes me wonder if there might be a cultural aspect there, right? That maybe people are more committed to their families. Maybe they're more likely to have to take care of their parents as they get older. But in any case, it's interesting to look at this map and think about why these numbers might look the way that they do. Now, since you all answered that question on the class survey, we can look at our data from our class and see how your responses compare to the ones that you see on the map here. As a quick reminder, if we want to use SPSS to generate a frequency graph, a histogram in this case, we're going to go to Analyze Descriptive Statistics Frequencies. We're going to select the variable that we're interested in, which in this case is how far away is your parents' house from campus. We're going to click on the Charts button, and we're going to select histograms because distance between your home and your parents, or sorry, distance between campus and your parents' house is going to be a continuous variable. When we ask for the histogram, we're going to see that our class data looks like this. So notice first, this is a grouped histogram where each bar represents a range of 50 miles. And the overwhelming majority of people in this class live within 50 miles of your parents, or campus is within 50 miles of your parents. That said, there's also a small number of people who live really quite far away from your parents, including one person who lives 500 miles away from their parents. I once did this, and I had a student whose parents lived in Brazil, who lived thousands of miles away from their parents. So those people are outliers. They're unusual extreme scores. Consequently, what we have here, if you think back to last class, is a positively skewed distribution. We have a peak over on the left and then a really long tail on the right. So we would call this a positively skewed distribution. Now, we haven't yet seen how to calculate means and medians in SPSS. We'll get to that soon enough. But for the sake of argument, I just went ahead and did it for you. In our class, the mean distance between campus and your parents' house is 55 miles, but the median is 35 miles. Notice how those numbers are quite different, right? And the reason for that, again, is because we have a small number of unusually high scores that cause the mean to go up. It does what we call, it inflates the mean, meaning it makes the mean larger than maybe it should be. It would probably be more accurate to say that the typical person in this class lives about 35 miles, their parents live about 35 miles from campus, meaning half of you are less than 35 miles, half of you are more than 35 miles. Here's another interesting example of how the mean and the median can sometimes tell us very different stories. If I asked you how many drinks the average American has per week, write down what your guess would be. And just to be clear, we're talking about alcoholic drinks here, so mixed drinks, glasses of wine, beers, and so on. And we're talking only about people above age 18. So how many alcoholic drinks do you think the average American has per week? Once you've written down your guess, let me explain to you what these data look like. So what I'm about to do is I'm going to show you what are called deciles of this distribution. In other words, I'm going to show you how many drinks per week the bottom 10% of people have, the next highest 10%, the next highest 10%, all the way up to the 10% of the population that drinks the most alcohol. So first off, you'll see here that in the bottom decile and the second and the third deciles, the average is 0 drinks. In other words, 30% of Americans don't drink at all. So they have an average of 0 drinks per week. There's another 30% of people who drink a very modest amount, less than 1 drink per week on average. So right now we're looking at 60% of the American population, and those 60% of people drink very, very little. Next, we move into the 7th and 8th deciles. So we're getting into the groups of people that drink a little more, but even so, they're not drinking an egregious amount of alcohol, right? The 8th decile, for example. So these are the people who drink more than most people, but not the most of everyone. They average about a drink a day, which is not unreasonable, I don't think. Then you have the 9th decile. Now remember, these are the people who are in the second highest group of drinkers. They have about 2 drinks a day, which is starting to get a little high. but maybe not unreasonable if you're the sort of person who, frequents happy hours or whatever it might be. Now, what I'm going to show you next is the 10th decile, or the top decile. In other words, these are going to be data from the 10% of Americans who drink the most. Those 10% of people, on average, drink, I swear I'm not making this up, 74 drinks a week on average. So this 10% of the population, the 10% of people who drink the most, they are averaging 10 drinks per day. So we end up with a really weird distribution here, right? If you think of it as graphing the number of people who drink 0 drinks, 1 drink, 2 drink, 3 drinks, etc. per week, we're going to have a huge bar at 0 because there are a lot of people who don't drink alcohol at all. On the other hand, there is a very small number of people, less than 10% of the population, who drink almost constantly. Just a crazy, crazy amount of alcohol in their system. So on the one hand, we have a lot of people who don't drink at all. On the other hand, we have a small number of people who are drinking a ton of alcohol. If using these numbers, we were to calculate the mean, we would say that the average American drinks about 10 drinks a week, 9.83 drinks per week. But if we were to go based off of the median American only has about 0.5 drinks per week. I would argue that neither of these numbers is actually a great measure of how much the average person drinks, right? The mean here, 9.83, makes us look like a bunch of lushes, whereas the median makes us look like a bunch of prudes, when in actuality, the truth is probably somewhere in the middle, right? So this might even be a situation where the mode might be useful, although the mode here is likely to be 0. So even the mode here doesn't tell the whole story. Anyway, let's talk about the mode. As I mentioned before, the mode is the most common score in our sample. Now, you will sometimes see the mode used with continuous variables, but the overwhelming majority of the time, the mode is only going to be used with categorical variables, telling us which category has the most people in it. So you might recall from the graph that Liz showed in class earlier today, the most common class year in this class was sophomores. In other words, the modal class year in our class would be a sophomore. Now, we can technically use the mode with either continuous or categorical variables, but it mainly just gets used with categorical variables. In contrast, the mean and the median, we are only going to use those with continuous variables. You cannot take the mean of a categorical variable. It just doesn't make sense. If I asked you, what is the mean religion, that's a nonsensical question, right? You can only calculate the mean and the median if you're working with numbers, not with categories. Importantly, we can also have more than one mode if we have two categories that are both the biggest and they're tied with each other, so they have the same amount of people. For example, here's some data that I just made up. Imagine that I have a class of 30 people, and I ask them to tell me whether they're a freshman, sophomore, junior, or senior. In this class, we have 4 freshmen, 10 sophomores, 10 juniors, and 6 seniors. Because both sophomore and junior are tied, so to speak, for being the biggest category, we would say that both of them are the modes. Sophomore and junior are both modes here. In statistics terms, we would refer to that as a bimodal distribution. Bi meaning 2, modal meaning modes. It means we have 2 modes in this situation. This is a fun example that I'm a little bummed that we didn't get to do together. What we see here is a map from 1984 that shows for each of the 50 U.S. states what the most common, or in other words, the modal job in that state was. So you'll see, a lot of states where secretary was the most common job. We have a cluster of states where farmer was the most common job. In the South, we have some truck drivers, factory workers, states where those were the most common job. Um, in Nevada, the most common job was recreation attendant. I will give you a hint that that includes people who work at casinos. So that kind of makes sense when you think about it that way, right? Why it's important to have our operational definitions here. Now, on the next slide, I'm going to show you the exact same map, but instead of being from 1984, it's going to be from 30 years later in 2014. Before we do that, though, I would like you to pause and think about what do we think is going to be the most common job in the largest number of states in 2014? How has the world changed between 1984 and 2014? Is it still going to be secretaries, or is it going to be something else? And why might it be something else? What is there a lot of now? So take a second to pause, think that over, and then I'll show you the next slide. Okay, here we go. So there's 1984 again. Here is 2014. Now you'll notice that we have some new jobs that weren't on the map before, right? Software developer, for example, that kind of makes sense. We also have teachers, were not on the map before, but now they are. But in 2014, the overwhelming majority of states, the most common job in that state was truck driver. Why do you think that is? What do we have today that we didn't have in 1984? Amazon, right? People buying stuff online. And we need people to deliver that stuff. The operational definition of truck driver here includes UPS, FedEx, Amazon, and so on. So that is, in many states, in all the ones that are in light blue here, that is the modal, the most common job. Now, as we look at this map, a few thoughts come to mind. First, there may very well be more truck drivers today than there were in 1984, simply because we need more truck drivers to deliver the stuff that we're buying online. There may very well be fewer secretaries in 2014 than there were in 1984, right? There's still a couple states, including Maryland, in fact, where secretary is the most common job. But there's actually, if you think about it, there's probably less need for secretaries in 2014 than there was in 1984, right? Way back then, computers weren't as good. We didn't have things like voicemail or answering machines or email. Even typing, right, wasn't something that everybody could do. It was a special skill that secretaries had. So as technology has improved, there's been less need, arguably, for secretary jobs. But technology can't drive trucks yet, so we still need a human to deliver my stuff from Amazon. Be careful about that, however. Remember, the mode only tells you what the most common job is. So while our intuition might lead us to think that the number of secretaries has gone down and the number of truck drivers has gone up, we don't technically know that for sure. All we know for sure is that in 1984 there were more more secretaries than truck drivers, and in 2014 there were more truck drivers than secretaries. But we don't exactly know how we got from point A to point B. A few more just simple examples of modes. I don't know if any of y'all made New Year's resolutions this year, but as you can probably guess, the most common New Year's resolution, which according to this large survey, 13% of people said was their New Year's resolution, is to lose weight. So that would be the modal New Year's resolution, the most common New Year's resolution. Interestingly, and we might play around with these data more later in the semester, but if you go to Google Trends, you can look at trends over time in Google search terms, things that people search for on Google. And you probably can tell that there's a very clear repetitive pattern here, right? Every year, right around New Year's, there's a spike in searches for the word diet, probably because people are trying to fulfill those New Year's resolutions. If you look a little closer at the graph, there's actually, every year there's a second little bump, maybe around April or so every year, probably when people are trying to get in, bathing suit shape. They're aware of the fact that they're going to be going to the beach in a few months when the weather's turning, and they want to lose some weight before they have to put their bathing suit on. Another large survey, they asked, the people in the survey were asked, how many partners have you said the words "I love you" to? And what they did is they broke down the answers by age group. So in your age group, 18 to 29, the average person, and by average I mean mode, the average person has said "I love you" to exactly one other romantic partner. In the slightly older 30 to 44 age group, the mode is now 2. And if you look at the third age group, the mode is still 2. That kind of makes sense, right? Those people are a bit older. They've probably had more romantic relationships, more serious romantic relationships. So consequently, they've said "I love you" to more people. But then interestingly, when you get up into, say, our grandparents' generation, right, 65 years of age and older, the mode goes back down to 1. It kind of makes you wonder if that's a reflection of a generational difference, right? Those might be people who didn't have as many different romantic partners because they either didn't have the means to do that, right? They didn't have, Bumble and Tinder back in the day. Or maybe there was just more pressure to marry young. So they found their partner and they married, and that's the only person they've ever said "I love you" to. If you tilt your head a little bit clockwise, you'll see that in each of these age groups, we have a positively skewed distribution, where there's a peak to the left, right? Most people, regardless of age group, have only said "I love you" to, say, 0, 1, or 2 people. But in every age group, there's a small percentage of people who seemingly are just going around telling everyone they love them. Even in the 18 to 29-year-old group, there's 1% of those people who have said "I love you" to an unusually high 10 or more romantic partners. We've sort of danced around this a few times in the examples that we've talked about today, but I want to explicitly touch on this point. In the last video, we talked about the normal distribution, and we talked about how a normal distribution is perfectly symmetrical, right? We have a lot of scores in the middle, and as we move away from the middle, those high scores and those low scores become a lot less common. In a normal distribution, the mean, the median, and the mode are all equal to each other. So if a distribution truly is symmetrical, all 3 of those measures of central tendency are going to be the same. In this graph, for example, the mean, the median, and the mode would all be equal to 100, right? It's right in the middle of the graph, so it's the median. It's the tallest point of the graph, so it's the mode. Now, we also talked in the last video about skewed distributions, positively skewed, negatively skewed. As a distribution gets less symmetrical and more skewed, these 3 numbers move apart. So what we have here is a picture of a positively skewed distribution where we have a much longer tail on the right. So this might be a graph of something like income, for example. Now, the mode is always going to be the highest point on the curve. So even in a positively skewed distribution, we see a peak over on the left. That's where the mode is going to be. But remember, the mean gets pulled upward by unusually high scores. So in a positively skewed distribution, the mean is going to get pulled to the right in the direction of those outliers, and then the median is going to be somewhere in the middle. So the more different those numbers are, that tends to be a hint that we might be looking at a skewed distribution. Last example that we're going to talk about in this video. Another one of the questions that I asked you in the class survey is if your friend told you they were having a party at 9 p.m., what time would you show up? The reason I ask this question is because there's this weird social phenomenon where if somebody tells you they're having a party at a certain time, most people will not show up at that time. In fact, they'll show up a little bit later than that. So, as we'll see in a few slides, what I did with your answers to those questions is I calculated how early or late you would show up to the party relative to 9 o'clock based on your answers. But first, let's see how other people answered this same question. The blog 538, which I draw a lot of examples from, they asked people the same question that I asked you all. And here is a grouped histogram showing people's answers. Notice that each bar represents 30 minutes of time. So 24% of people said that they would show up within 30 minutes of the advertised start of the party. So if they were told that the party started at 9, they might say, okay, well, I'll show up at 9:15 or 9:20. Some people are showing up even later than that. So this bar, for example, shows us that 20% of people are showing up between 1 hour and 90 minutes after the advertised start of the party. So if the party started at 9, these people are showing up between 10 and 10:30. There's some people that show up really late. 1% of people would show up more than 4 hours late. So if the party started at 9, they're not getting there until 1 a.m. On the other side of the distribution, there's a subset of people, 9%, that actually said they'd arrive early, before the party was supposed to start. Again, if you sort of rotate your head clockwise, you can see that we're dealing with another positively skewed distribution here. Most people show up within the first 90 minutes of the advertised start of the party. But there is a tail that extends out to the right to account for these small number of people that are showing up 3-4 hours late. Now, I've encouraged you to try to not think about variables as individual things, but to think about how different variables might relate to each other. One other thing that they looked at in this study is they wanted to see if the time that people show up to a party depends on how many people were invited, the size of the party. As you can probably imagine, there's more pressure to show up on time if the party is smaller, and less pressure to show up on time if the party is bigger. So what they did is they took all the parties from this study and they divided them up into big and small parties, and they defined a small party as having less than 25 people and a big party as having more than 25 people. Notice how the shape of the distribution kind of changes depending on the size of the party. So if it's a small party, and we look just at the red bars on the graph, most people are showing up pretty early to a small party, right? 33% of people are showing up in the first 30 minutes. 18% of people are actually showing up early to the smaller party. Whereas for the bigger party, the mode, 23%, this yellow bar right here, the mode is actually between an hour and 30 minutes later. Both of these distributions are positively skewed, but for the smaller party, the skewness is worse, right? You can tell that there's more severe skewness if you look at the shape of the red bars compared to the shape of the yellow bars. And the mode changes also, right? The mode gets later when the party gets bigger, which is probably what you would have expected. Now, what about our class? You all answered this question, so I know how early or late you all would show up to the party. Here is the histogram that shows for our class when people would show up. The mean here is 41.26 minutes, and the median is 42 minutes. So the typical person in our class, if the party was starting at 9 o'clock, the typical person would show up around 9:30, 9:45, according to your answers. Now the mode, for what it's worth, was 60 minutes, as you can see by that tallest bar on the graph. So that was the most common answer, was people said, yeah, I'd show up at 10 o'clock if the party started at 9. But the fact, remember from a few slides ago, in a symmetrical distribution, the mean and the median are going to be equal to each other. In this case, they're only 1 minute apart. So I would say that in our class, the distribution is actually pretty symmetrical, right? Most people would show up between, say, 9:30 and 10 o'clock, but we also have a lot of variability here. There was one person in the class who said they wouldn't show up until 2.5 hours after the party started. They wouldn't show up until 11:30. There were 2 people who said they'd actually show up an hour early. They'd show up at 8, even if the party wasn't supposed to start until 9. So this brings us to an important point. Everything that we've talked about in this video is about measures of central tendency, finding ways to take a distribution and distill it down to just a single number that represents the average. However, as we will see in our next class next week, that's not good enough. In addition to knowing the average person, when we're doing statistics, we also need to know something about how spread out the scores are. Or in statistics terms, we call that variability. We could easily have a distribution where all the scores are very similar and a distribution where all the scores are very different, but the average is the same, right? So if I tell you, for example, that I gave you an exam and the average grade was an 85, maybe everybody got an 85, or maybe some people got hundreds, some people got 70s, and it averaged out to an 85. Those distributions will look quite different, even though the means are the same. So anytime we talk about a measure of central tendency, an average, we're also going to have to talk about a measure of variability. It's not enough just to know the average. We also need to know how spread out the scores are. So what we're going to talk about next week, in the same way that today we talked about 3 measures of central tendency, next week we're going to talk about 3 measures of variability. How do we explain how spread out these scores are?